Okay, good evening, guys. So, welcome to my second session, robotic design and manufacturing number two. So, in this session, I am going to complete the 3D printing, like introduction to 3D printing. So, let me talk about like what is 3D. Like most of here know what is 3D printing. Low, I'm just covering the basics part. So, we call the 3D printing as additive manufacturing. We like in normal conventional manufacturing methods, what we are doing is the removing material. Normal milling, lathing, like so many, there are so many operations. So in all those operations, what we are doing is the removing materials. But the difference in between 3D printing and the normal conventional methods is like in 3D printing, like we add materials. That is why we are calling this as additive manufacturing. So basically, we are joining materials to make a part from 3D model data a layer by layer. So 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 in 3D printing, like we can get a physical model using a digital model very easily, like in very fast. Like when we talk about the normal normal conventional manufacturing method, it is very it is not easy to get a customized part that much fast like 3D printing. So that is why 3D printing is so much important when we talk about prototyping, manufacturing, and robot designs. So when you talk about like histories, Hideo Kojima, the present the first concept in 1980, and Charles Hulse introduced the SLA and commercial 3D printing in 1987, and in this is now after 2000. So we nowadays even a home has a 3D printer also. Like everyone use 3D printers very easy. So why 3D printing matters. So basically, again, I'm telling that like, oh, normal method is like subtractive manufacturing, like we remove material, and like in here we are adding material. Like normally we can do, like we can build anything. Basically anything you can print anything you want, like any shape, anything. But in subtractive material there are many constraints when you are like designing things. So that is the most important thing in 3D printing. So like you can customize design freedom and sustainability, like low waste. Like you like when we talk about removing material, the removing material is waste. So that is the most like advantages in 3D printing. So and there's another thing, like in nowadays, like it's a very large global market also. Like if you are thinking you are going to 3D printing market. So yeah, that is why 3D printing matters most in manufacturing. So yeah, this is the most important part. What is the workflow? Like the basic workflow from a start. Beginning to it. The first thing is, yeah, definitely you need to have a design. You need to have design. You are like you need to create a design using using a CAD model like Fusion 360, SolidWorks, like Onshape, anything you want. There are so many CAD softwares available. Like you can design anything you want. Okay, and get a design. And the second part is file preparation. So basically, every 3D modeling software has their own like their own file type in their own 3D modeling file type. But so like that file type cannot be understand by the 3D printing software. So we need to we need to prepare that file. Like we need to convert that file into a STL. Normally the most popular method is STL file. STL file or 3MF or BG file, like that can like it can understand by the 3D printer. So then after that, what you should do is the slicing part. Like it is done by the 3D printing software. Like in almost all the 3D printing softwares is doing this method, the slicing method. Like basically what it do is converting that 3D model into the G code. G code means like it is giving instruction to where should the nozzle go when it is 3D printing, where should the nozzle go. Like it is basically programming the nozzle or the method that 3D prints inside the 3D printer. So after that, like three printing printer setup and basically printer setup and print, like you after you get the slicing part, you will have a unique file that unique to that 3D printer. Then you can insert that file into the 3D printer, and like after the basic setup like loading materials, like level the weight calibration, like everything that need to be done before the 3D printing. So after 3D printing, what you do is the post processing. Like there can be like defects, and there are so many supports in the 3D design. Likewise, there are so many things that you need to remove supports. Like if there are like small defects, like you can use a material called catalloy paste or something like that to fill that defects. Likewise, you can do the post processing things and clean the 3D model and get the final 3D model. So this is the basic workflow from beginning to the end. If time allows, like I will show you how the file preparation and the sizing method will work uh, uh, after end of the session. So okay, so think like you need to do a 3D printing for your project or some like project, or to like you are developing a prototype or something like that, you need to do a 3D printing. So there are so many 3D printing technologies out there. So these are the base like main four categories, like main four categories that you can 3D print your design. So basically, the first one is like they are the extrusion, resin-based, powder-based, and advanced 3D printing technologies. Like I won't explain these things one by one because like in the next slide there are four videos that explain everything. Like it is good. It is like explaining using a video is good rather than explaining using the word. So I will explain it in there. So in extrusion category, there are technologies called FDM, CFR. There are like so many different. There is no big difference. Like the same technology is using the FDM and CFR. Like FDM printers is that you can see in the like so many places, like where the nozzles go around the bed and like print the layer by layer. That is the premium printer, and CFR is also like that. So resin based printing that uses SLA, DLP, LCD technologies, and powder based is SLS, DMLS, and EMB. And advanced is MJF and binder jetting. Like there are some technologies, but the category is the under these four categories. So yeah, let's go to the next slide, and yeah, like you can get an whole idea about what are these technologies.
This is our nylon 3D printing factory.
Yeah, this is the first one, the extrusion category, and this is the FDM printing. Basically, the nozzle is go around the bed and print the whole thing. Like see, this is the most common one. Like you can see this is in the everyday life. So basically, yeah, this is the FDM printing. So this is the SLA, like the
Bought my first 3D
resin
printer
printing.
after I watched the video about 3D resin liquid printing versus filament 3D printing. The filament printer was amazing, and there were so few steps on starting. But in the back of my head, I was saying, wow, I wish I can get a lot more
This is
details
the
with my
bed.
3D prints. I was afraid of getting a resin
And
3D printer at first because there were so
instead
many
of
extra steps when it comes to
plastic
processing your models that you
strips
print.
like this
Now, I
is the
seldom
bed.
use my filament printers,
Isn't
and I
it?
use primarily my resin printers like this
And the bed
Anycubic
goes into
Photon Mono
the
X2. If you scroll all the way down to the bottom of my TikToks, you'll see that I started with a
as a
pencil
like
and a piece of paper, and now we're
unit
doing
line
3D printing.
under
What?
the bed, and it solidify that liquid a layer by layer. Okay, so it's solidify like in here. It's
X2. If
after
you
the bed
scroll all the way down to the
solidified
bottom of my TikToks, you'll see that I started with a pencil and a piece of paper, and now we're doing 3D printing. What?
one layer is solidifying one by one, like it will get this final design. Okay, so I will explain what are the differences in this FDM, SLA, powder, and MJF 3D printing. When you are designing something and when you want to 3D print something, you can choose what is the best 3D printing method that you need. Okay, so
For
this
some
is the
3D printing
powder.
magic, we found this model of a seemingly floating illusion cube and
These are the
decided to
normal
3D print it with SLS.
FDM, SLA, and powder and MJF.
Once the laser of our Syncotech S2 has fused the particles together, we can unpack our powder cake. All we have to do is clean the part of the residual PA12 powder. As the cube is surrounded by unsintered material, we do not need any support structures. And just like magic, we go from powder to a solid object. What would you print with this technology?
See, instead of resin in SLA, in this powder,
The particles together, we can unpack our powder cake.
Powder.
All we have to do is clean the part of the residual PA12 powder. As the cube is surrounded by unsintered material, we do not need any support structures. And just like magic, we go from powder to a solid object. What would you print with this technology?
And it can get this 3D design. So this is the last one.
This is our nylon 3D printing factory workshop. Traditional mold opening and injection molding method. Time-consuming and labor-intensive and not suitable for small batch customization. The whole process is efficient and smooth. Importing 3D models into the machine. Multiple print heads efficiently print metal powder into solid parts. Only 17 hours. A cylinder filled with various shaped parts has been successfully made. The product precision is up to 20 microns, allowing all kinds of complex details to be perfectly presented. After printing, it can be used directly as a finished product. Such a device is worth the equivalent of 1,000 standard desktop 3D printers. For bulk customization of nylon parts, come to Union Fob.
Now, as you can see, this is one of the most advanced 3D printing method that used in this in the industry right now. Like you cannot use this in a home or a small company. Like they whole big manufacturing companies use these kind of things. It can go up to 20 microns high precision, and it can print the multi-material, like multicolors. Like you can do so many things with this printing method. Yeah, so yeah, this okay. Now this is the comparison. This is the comparison in between extrusion, resin based, powder based, and advanced 3D printing. Like you can choose whatever you want after comparing this when you are designing something. So when you talk about the working principle, I already talk about this about the working principle. In extrusion, like melted filament is extruded through the nozzle that goes to the bed, and in resin printing, UV lights on the bed cures the liquid resin and layer by layer, layer by layer. So and in powder based, the laser fused powdered material, the laser fused powdered material is the one who done the 3D printing. And as for the advanced, the last one, it is a fusion or binding powder using agents and lights. So even I don't have that much knowledge in the powder base and advanced. Like they use powder materials, like he can get a lot of precision, and so they can do so many things. Yeah, so in the material, when you talk about the materials, think you need to print metal object, then you cannot use the extrusion or resin based printing. Normally, there are some extrusion based metal printers in the world, but it is very rare. Okay, so normally in the extrusion and resin based printers we use the plastic based materials go like PLA, ABS, carbon fiber composites, and uh, photopolymer resins, photopolymer resins. Those are the things that use in the extrusion and resin based printing. And in powder based and advanced, it used like you can go to metals like stainless steel, titanium, alloys, nylon, and the plastic can be also print, and the full colored composites, so many things. Like you can go up to plastics to metal to composite in when we talk about advanced 3D printing. So yeah, that is about the material used. And when we talk about the precision and surface finish in extrusion, like extrusion 3D printing, it is like moderate, and you can see the layers. Basically, you can see the layers in extrusion 3D printing. Like most of, like all of you have seen 3D printed 3D like extrusion 3D printing objects. So they have small layers like uh, where the nozzle goes. And in resin based, you can get a high precision and a smooth surface. Okay, like that is the main difference between extrusion and resin base. Like as you know, like we cannot go to the powder base and advance, like we cannot go to the powder base and advance 3D printing. Like it's very costly, and like it is hard to find in Sri Lanka also. And like when you are doing when you are building a prototype or prototyping, like we no need to go to that thing. So what matters is the surface and the precision. Sometimes you no need that much precision and the surface, and sometimes you need smooth surface and high precision. So basically, if you no need to think, if you don't think about the precision and smooth surface, you can use the extrusion based 3D printer. If you think about the precision and smooth surface, you can get a very smooth a surface in resin based 3D printer. You can go to the resin based 3D printer. And when we talk about the typical cost, the extrusion is the most low cost, and it can be low to medium. And in when we talk about resin 3D printing, it is go to medium to high. And powder base and advanced is very high cost. And for the applications, I think you can use this to anything like prototyping, education, dental, aerospace, industry production. Like guys, when you go from extrusion to advanced, the application range is going to get bigger. So I think you can get you got an idea what you should choose when you are going to 3D print your 3D model. So this is the this is the so I have completed the comparison of 3D printing technology. Yes. Okay. So I think we have time. So let me show you this one, like how to design, how to do the file preparation and the slicing part. Like you can get a like small idea. Like I think it's better to know how to do this because like everyone needs 3D printing these days. Uh, yeah. So let me share the screen. Entire screen share. Yeah, I think you can see my entire screen. So, okay, so yeah, this is our own shape. So, this is our own shape, and this is a 3D model uh, that I have done before the session. As you can see, so this I think, yeah, I will rotate the 3D model. So I want to print this one. Okay. So this is the 3D model. So I have done the 3D modeling part. So the next part is the file preparation part. So if you go to this place and right click it and choose the export, and you can export any format you want. So the most popular method is STL. So I'm going to choose the STL, and as for the STL format, we are choosing binary. No need to choose text. It is binary, and units are millimeter. And in the resolution, there are like three main resolutions, like fine, medium, coarser, and always choose the fine as a resolution. The resolution means like this. Okay, think about this edge. Basically, think about this edge. Okay, if you do like, it is like, if you choose coarse, like in 3D printing, it will be like this. Okay, you cannot get this edge smoothly. Normally, that is the thing when we like, when you go to a low resolution. If you go to a high resolution, like you can get these edges very accurately. So always choose, even if you choose resin printing or the extrusion FDM printing, always choose the fine resolution as your resolution. Like it will give you an better 3D print. And yeah, you can download it. Just I'm going to export it. Yeah, I export it, and as for the 3D printing software, I am using Anycubic Photon Workshop, which is used to 3D print. This is the resin 3D printing software. The second one, I think you can remember the second one, which is like the bed is going into the liquid and 3D printer one layer at once. So this is that kind of printer, and this is its software. So basically what you need to do is just get this 3D model into your 3D software, and like it will come to this bed originally. So as you can see, like this is the bed size. See, this is the bed size and length and the width, and this is the height. Okay, this is the maximum height that you can print. So like in this cube, you can see the all the dimensions that you can print. So yeah, so this is inside the box. Yeah, okay. Like using this move button, like you can move the, see, like you can move up, down, anything you want. You can do anything you want. Like in the rotate, you can rotate this. See, yeah, like you can do anything you want. And yeah, as well, like if you want to scale this one, you can scale it, and the mirror option is there, and some layout option. I'm not going to explain all these things. So basically, moving and rotating, think like think the 3D model is imported like this. Okay, so you need to yeah, like you need to get this 3D model into this bed. Okay, so you cannot 3D print like this. So there will be so many there will be a lot of supports and so on. So always when you are 3D printing, you need to grab your 3D print into this bed. Okay, that is the first thing. And see, there's a option called on platform. So it will like, see, it will touch the platform. It will touch the platform like almost, or every 3D printing software has this kind of quick options. And I'm going to move to the center. Yeah, and as for the rotate by face, I'm going to use this one. See, if I, yeah, now you can see it is now it is in a good position. Okay, so as you can remember, in resin 3D printing, it will print like this. Okay, normal in extrusion 3D printing, like the nozzle like go like like this, and it will 3D print the part. But in resin 3D printing, like it will 3D print like this. Okay, it will first 3D print this layer, then after that this layer, like there will be like thousands of layers. Like it will print like layer by layer. Okay. So the next thing is, when you're 3D printing, normally in resin 3D printing, we don't place the 3D object like this. We are having a small rotation like this. It is because like now I am explaining like what is the thinking pattern. Okay, by basically thinking pattern when you are preparing your 3D print. Okay, what it done is like it will 3D print a layer by layer. Okay, if we place it like this, it will print full. It will print this full layer, and again this full layer, and full layer, and it will print all the layer. And it means at the end, so it means like after it print this one, this full, I don't think uh, like I will explain this as more like, I think you can understand this thing, right? Because most of you are not familiar with these things. That is the reason. Like the whole layer will get the full weight when it is printing. Okay, the full weight. So that is why we are having a small rotation here. Okay. Then the weight will, so in here it will print this small layer. Then it is gradually, this layer size is gradually increasing. It means like the 3D model weight is gradually increasing. Okay, gradually increasing, like it will be it is good because when it is gradually increasing, because like when we talk about like this is solidifying, no? First layer is solidifying, second is solidifying, like it takes time. If the weight is gradually increasing, like then these layers are already solidified, so it has time. Okay, then you can get a good print. Okay, I think you can understand what I told you. Just don't think if you cannot understand, because uh, this is not familiar to you. Okay, so I prepared my 3D model. After that, you need to do is get the supports. You can choose light, medium, and heavy. Normally, it differs according to your size of the 3D object. This is a small object, so no need to go to heavy. Just light support is enough, and just click this button, and it will generate the supports. Okay, like you can customize the supports using this, like support, and you can change the support angle and the anchor distance. Like you can change so many things, but normally we are using this default light, medium, and uh, heavy method, because this is a normal 3D design. When we talk about complex 3D designs, like you need to manually generate supports. Okay, as you can see, I think you can clearly see the supports. See, this is the support. Okay, okay, this is the support, and it will print like this. First print like this. Okay, I generate support. Then this is the slice. See, this is the slice button. Like it will convert this 3D model into the G code. Okay, now I am going to like it will take time. To enable 3D. Okay, so now we can see how 3D printing will work. Okay, so this is the first layer. See the layer 1, layer 2, layer 3, 4, 5, 6, 7, 8, 9, 10, 11. Likewise, see this is the layer, like it will print by layer. See, so you can see the only in here you can see only one layer, and in here you can see it in the 3D manner. See, what I said is this. See, like this, the weight is gradually increasing. Unlike in flat, the weight is gradually increasing. See, okay, yeah. Likewise, as you can see, it will take about 122 milliliters, and estimated time is 4 hours and 17 minutes. Like it will take time. Okay, like it will take time when we talk about resin printing. Like it will take time. Yeah. That is the thing, and you can save this slice file and input that into the 3D printer, and you can 3D printing. So this is the basic stuff from 3D modeling, then file preparation and the slicing part. That is how the 3D modeling, the 3D printing works. Yes. Yeah, I think I completed everything, like about 3D printing. Introduction to 3D printing, like we can go to the advanced things in upcoming sessions. Yeah, that's all. Thank you. Hope you enjoy the session. Okay, thank you.